let's take a look at this review problem. The limit as x goes to pi of cosecant of x minus cotangent of x. This has the form infinity minus infinity. Cosecant of pi and cotangent of pi are both undefined. And so this has one of the indeterminate forms. And so we will somehow manipulate this so that we can use L'Hopital's rule directly. So cosecant of x minus cotangent of x. And what we will do is we will use a trig identity. So cosecant of x is equal to 1 over sine of x. Cotangent of x, well, there's a couple of options and they both work, but probably the easiest option is to write this as cosine of x over sine of x. We also could have done 1 over tangent of x. That also would have worked. Now, the reason I chose cosine of x over sine of x is because I can now get a common denominator. So the limit as x goes to pi of 1 minus cosine of x, whole thing over sine of x. Okay, now as x goes to pi, the bottom here is undefined. Sine of x is undefined. The top, cosine of pi, is actually equal to -1. And so here we actually do not need to use L'Hopital's rule at all. We have now massaged this so that we now have something where I have cosine of pi is 1 minus -1. That's equal to 2. And on the bottom, the sine of pi is equal to 0. So I have the form 2 over 0. L'Hopital's rule does not apply, and so this is just simply undefined. It blows up. And if we take a look at the graph of cosecant of x minus cotangent of x, we see that the graph indeed does blow up at about pi right here. So here it blows up positive, coming this direction it blows up negative, and I'll actually confirm that those one-sided limits do happen, that the limit from the left is going to be plus infinity, the limit from the right is negative infinity. But here, L'Hopital's rule turns out to be not necessary. We've changed this into a quotient, and we no longer have to use L'Hopital's rule. We can simply read off 2 over 0. That's undefined. All right, now for the sake of argument, let's see what happens if I had used a different identity instead of the one that we just used. So starting the problem over, limit as x goes to pi of cosecant of x minus cotangent of x is equal to the limit as x goes to pi of 1 over sine x minus 1 over tangent of x. Okay, and then we combine limit as x goes to pi of tangent of x minus sine of x over sine of x times tangent of x. Now, written this way, I do have the form 0 over 0. And so had I chosen to use the this trig identity, I would have 0 over 0, and so L'Hopital's rule would indeed apply. And so by L'Hopital's rule, this is equal to secant squared x minus cosine of x over, and on the bottom here, derivative of the top of first times the second plus the first times the derivative of the second. Okay, now what happens here? Well, we get 1 minus 1, and that's 0 again. Over here, we get tangent of pi is equal to, I'm sorry, I misstated myself. As x goes to pi, secant of pi quantity squared, that is equal to 1. Cosine of pi, that's equal to -1. So on top, we have 1 over -1, which is equal to 2. On the bottom, if you plug in pi, we get 0 here. We also get a 0 here, and so we get 2 over 0 again. And so this again will be undefined because you can't have 2 divided by 0. That does not make sense. So we get the correct answer either way. This way, we do not need to use L'Hopital's rule at all. We can just read off that this is going to be 2 over 0, so that's undefined. This way, we have, if we plug in pi, we would have 1 minus -1, which is equal to 2, divided by 0 here. And so that is undefined as well. So 2 ways, one in blue, one in green here, of solving the problem. The way in blue here used this trig identity, and as it turned out, L'Hopital's rule was not necessary. For the one in green, we used this trig identity, replacing cotangent with 1 over tangent, and it did prove that L'Hopital's rule was necessary using the second method.